Now for the good part, the unit circle. Let me just begin by labeling my axes. That's the x-axis, and that's the y-axis. Now what I'm going to do is I'm going to go ahead and label all the degrees going around this circle. Before I do that, let's just notice a couple similar triangles in here. So if you look here, if I were to draw this as a triangle, that's going to be congruent to this triangle at the bottom. Same thing if I drop that, that's congruent here. So what this is showing me is whether I'm thinking of this angle or all the way to here, they have the same reference angle, just like we talked about in the last video. And all the way to here, same reference angle again, because it's the same amount above and below the x-axis. So I'm just going to go ahead and color off all the ones that are the same. That'll help us a lot coming up in a minute. So I'm not going to draw all the congruent triangles, but these again have the same reference angle, same amount above and below the x-axis. All right, so let's think about the degrees here. So first of all, we always start measuring our degrees by beginning on the x-axis on the right side. So right here, if I haven't moved that at all, I haven't gone anywhere, so that's going to be 0 degrees. This is the same angle as if I went all the way around and back where I started. If I think about it as going all the way around, that's 360 degrees. So if I go up to here, I've gone 90 degrees. Just making a right angle. Keep going. So going all the way to here is the same thing as going in a line, and that's 180 degrees. Or you think of it as doubling 90. So from 180 down to here, I'm adding 90 degrees. And that's going to take us to 270 degrees. And then another 90 is up to 360. Same thing really is 0, back where you started. All right, let's now look at these orange angles. So if this is 90, this orange is halfway to 90. That's going to be a 45-degree angle. From 90 to here, I'm adding 45 degrees. So that's going to be 135 degrees. From 180 to here, I'm adding 35 degrees. Again, just moving clockwise all the way around. So that's going to be 225 degrees. Down here is 270. Add 45 to 270, and we're going to get 315 degrees. And then we're back up to 360. So those ones are taken care of. Let's look at the purple angles now. So this, you can kind of see, the purple goes around by thirds. So that's like a third, 2/3, 3/3. So if that's 180 degrees, and this is 1/3, that's going to be 60 degrees. And now we're going to swing around by adding 60 degrees each time. So 60 plus 60 is 120 degrees. Add 60, we're back at 180. Add 60, and we're going to be at 240 degrees. Add 60, we're going to be at 300 degrees. Add 60 again, and you're at 360. All right, last ones are the blue angles. This, you can kind of see, is half of 60. So that's 30 degrees. So you can definitely count off by 30. You go 30, 60, 90, 120, add 30 again, and that's 150. You could also kind of think of this as stopping 30 degrees short of 180 to get the 150. So 180 plus 30 is going to be 210. We can think of it as adding 30. So add 30, got that, got that, got that. Add 30 to 300, and we get 330 degrees. Or again, it's stopping 30 degrees short of 360. So that's why it's 330 if we subtract 30 from 360. So that's all of our angles for the unit circle in degrees. Let's now think about what they would be in radians. So we know the conversion that 180 degrees is the same thing as pi radians. So if we go pi to here, and then pi again, that takes us to 2 pi. And we also know that conversion too, that 360 degrees is 2 pi. If we think of it as the 0 angle, then that's just going to be 0 radians. So whether you think of this as not moving at all or moving all the way around, it's the same angle. We're going to talk more about what those angles are called later. Okay, so 180 degrees is pi. Well, if we're stopping half of the way there, we're going to be at pi halves. Just think of it. 180 divided by 2 is 90. Divide pi by 2, and you get pi over 2. Now, if I'm here and I go to here, I'm adding that pi over 2. So it's 1 pi over 2, 2 pi over 2, 3 pi over 2. And then add one more, and we get 4 pi over 2, which just simplifies to 2 pi. Next, we'll think about the orange angles in radians. So, how does 180 compare to 45? Well, 45 is a quarter of 180, and you can see that this is broken into 4 quarters. So that means that 45 degrees in terms of radians is going to be pi over 4. And now let's just swing all the way around by pi fourths. 1 pi fourth, 2 pi fourths, 3 pi fourths. Makes sense. This would be 4 pi fourths, which is pi. So we're 1 pi fourth before it. Add pi fourths to 4 pi fourths, and we'll get 5 pi fourths. Add pi fourths again, 6 pi fourths, add it again, 7 pi fourths. Add it again, 8 pi fourths, which would simplify to 2 pi. So again, this is really just a quarter of pi beyond, so that's how I get 5 fourths pi, and this 7 pi fourths is a quarter short of 2 pi. Next, let's look at the purple angles in radians. So how do I get from 180 degrees to 60? I get that by dividing by 3. And we can see again, 60 degrees is 1/3 of 180. So in radians, I'm dividing the pi by 3. So 60 degrees is pi thirds in terms of radians. And let's swing pi thirds all the way around. So 1 pi third, 2 pi thirds, 3 pi thirds, same thing as pi, 4 pi thirds, 5 pi thirds, and 6 pi thirds, same thing as 2 pi. Time for the blue ones. Okay, so 180 degrees is pi. How does 30 degrees compare? That was 180 divided by 6. And we can see that 30 degrees is 1/6 of 180. So, if 180 is pi, this is going to be pi 6. It's a little more awkward to count up all the pi 6 going around. So it might be easier to think of this as how much did you fall short. So if this is 6 pi 6 and I'm going 1 pi 6 less, that's going to be 5 pi 6 here. If you don't like that idea, you can certainly swing all the way around and count it up. That would be 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6, 6 pi 6. Add 1 pi 6, that'll take us to 7 pi 6. 8 pi 6, 9, 10, 11 pi 6. Or again, think of falling short 1 pi 6 of 2 pi. Well, 2 pi is really 12 pi 6 if you just gave it the common denominator. And then we're 1 before, so we're going to be at 11 pi 6. So the most important thing to know with the unit circle is just to be comfortable trying to get these angles. So do a lot of practice, making sure that you're okay with how to convert between the degrees and radians. Coming up later, we're going to see how to use these. Okay, so those are all the angles. Next thing we're going to try to figure out are the coordinates of all these angles going around. So again, this is the unit circle, so it means that the radius is 1. So if we start here, all we've done is move the radius in the x direction. So this is really the coordinate point 1, 0. Our x value is 1 and our y value is 0. At the top, I haven't gone left or right, so the x coordinate is 0 and my y value is 1 because I have the full radius at the top. So you can keep using that idea. This point has an x value of -1, but its y value is 0. At the bottom, my x coordinate is 0, and my y coordinate is -1. For the other points, we want to review the fact that our x coordinate is given by our cosine theta value, and our y coordinate is given by our sine theta value. So, if you've memorized the sine theta values for 30, 45, and 60 degrees, that will give us the y values. And if you know the cosine values for 30, 45, and 60 degrees, that'll give you your x values. You might also find it helpful to just bring back that mnemonic, all students take calculus, because that tells us which trig function is positive in each quadrant. Okay, so let's go through with our cosine values. So we're going to give all our x coordinates first. Okay, so right here, our x coordinate is given by cosine. Cosine of 30 is √3/2. Here, cosine of 45 is going to be √2/2. Here, cosine of 60 is going to be 1/2. If you look at this, √3/2 is the largest. √3 is bigger than a √2, and that's bigger than a √1, and the denominators are the same. So that makes sense, right? When we're at a smaller angle, our x coordinate's bigger. Moving this way, our x values are getting smaller. So you can use that to help you remember this too. Let's keep going around. So if I move into quadrant 2 now, I'm now looking at negative x values. And now we have to really start thinking about the reference angles. So these two, the blue ones, have the same reference angle. They're the same amount above the x-axis. So that means they're going to have the same x coordinate. It's just that this one's positive and that one's going to be negative. So right here, it's going to be negative √3/2. The orange ones, same reference angles, same absolute value to their x coordinates, but that one's positive, that's negative. So negative √2/2, same idea up here, and that's going to be -1/2. Down here, again, our x values are negative. So cosine is negative. So this point has the negative √3/2. Orange is our negative √2/2. And the purple has the same reference angle, same x value, -1/2. Finally, in quadrant 4, cosine's positive again, because we're moving this way. So, same values for purple, positive again, orange, positive, √2/2, and blue is the √3/2. Okay, let's go through and now fill in our y coordinates, which come from the sine values. So sine of 30 degrees is 1/2. Sine of 45 degrees is √2/2. Sine of 60 degrees is √3/2. Notice again, here the y values are getting larger. That makes sense because as we swing this way, we're moving up in our y values. So the rest of the sine values, which give us our y coordinates, I didn't show this in the video, but if you just look here, In quadrant 2, sine's again positive, so same y-coordinates for the same angles that have the same reference angle, so root 3 over 2, root 2 over 2, 1/2. Now in quadrants 3 and 4, our y values are negative, so our sine values are negative. So find the ones with the same reference angles. They'll have the same y coordinates, but here they're negative, negative, negative. So that's how we figure that out. So what you shouldn't try to do is memorize this entire unit circle. All you really have to know are the sine and cosine values for 30, 45, and 60 degrees, and then you just have to know that x is cosine of theta and y is sine of theta, and that will give you all of these. So coming up, we're going to work with problems where you might be asked, what's sine of 210 degrees? All we're going to think about is the reference angle, ask ourselves what the sine value of that reference angle is, and then just the sine. So for example, if we had to do sine of 210 degrees, that has a reference angle of 30 degrees. Sine of 30 is 1/2. So in quadrant 3, sine is negative. So we would just say sine of 210 is negative 1/2.